Hello, in this brief footage we are going to discuss the subtopic in organic chemistry, the subtopic of alkanos. Alkanos are derivatives of alkanes. They are derived, so they are derivatives of alkanes. And they contain the OH group, so they contain the OH group as the functional group. Of course, the functional group is a characteristic, is the elements that give that compound the characteristics. Of that compound. The common name for alkanols is alcohols. So that's a common name. Of course, it is the UPAC, International Union of Pure and Applied Chemistry. That's the standard name internationally, it's the UPAC name. Now, when you talk of derivatives, it means that these elements, these compounds rather, they are derived in the sense that if we start with methane, now methane is CH4 and the structural formula is a carbon atom attached to 4 hydrogen atoms. That being the case, if we replaced this hydrogen ion, if we replace it with OH, then the resulting compound will be CH3OH with the structural formula COH, and of course the rest are hydrogens. So we call this methanol. So methanol is the first member of the homologous series of alkanos. The second member will be derived from ethane. So from ethane we have ethanol. So ethanol will be the structural formula will be like that of, similar to that of ethane, except this time it will have an OH as the functional group. That member will be propane. Propane will be similar to will give the alcohol derived from propane will be propanol. So propanol will have 3 carbon atoms, similar to the parent alkane, which is propane. But then finally it will have an OH there as the functional group. So we can see in the nomenclature, we replace the suffix N with all. We replace with all, so that we have methane, methanol, ethane, ethanol, propane, propanol. So we are replacing the last part of the name with the OL instead of N. Now, when it comes to isomerism of alcohols, which of course the UPAC name is alkanos. But most of the time, in very many books, in common talk, most of the time you hear of alcohols. So the isomerism can be positional or structural. Isomerism, this is where there's branching. For example, we can talk of ordinary propanol was a straight chain carbon-carbon chain. So this is basically propan 1-ol. So the one here showing the position, this is position of the OH group. So that is that letter, that numero, that number denotes the position of the OH group in the chain. Now suppose the OH group was some other place, say at the second carbon atom, then we can have the structure as OH, C, of course the rest are connected to hydrogens. Now this one will be propan 2-ol, where 2 is the position of the OH, which is the functional group in this case. Suppose we go to the next member. The next member of the alkano series is butanol. So butanol will have the 4 carbon atoms similar to alkane, but then with an OH. So the structure will be 4 carbon atoms, all hydrogens here, but with one OH group. So this can be butan 1-ol. That's the name of that structure. And then isomerism can result from the variation of this OH connection to the various carbon atoms, so that we may have butan 2-ol can be the structure OH. So you can see if we start counting from the side where the functional group comes soonest. So we consider that one to be number 1, number 2, number 3, number 4. Or we could not start from this side, because this would result to 1, 2, 3. So we start counting from where the functional group comes soonest, to give preference to how soon the functional group comes in the chain. Now there could be other possibilities of structural branching, so that we have C, OH, C, and then we may have a branch here of CH3, something like that. So you can see that the longest carbon chain has got 3 carbon atoms. So the root name will be propan. The propan in the second carbon atom, you can see 3 carbon atoms. At the second carbon atom is where you have the OH. So we have propan 2-ol. But then there's a branch here of methyl group. This is a methyl group. So we have the branching is at the second carbon atom, and it's a methyl group. So we call it 2-methyl propan 2-ol. 2-methyl propan 2-ol. It could also be possible to have CH3, COH. Of course, the rest are hydrogens. Then the branching is still at the second carbon atom, so you can call this one 2-methyl propan 1-ol. So these are 4 actually. 1, 2, 3, 4 isomers. 4 isomers of butanol. Yeah, 4 isomers of butanol. Something else is classification of alkanols, alcohols, as primary, secondary, and tertiary. So I'll use this short form for primary, secondary, and tertiary. First degree, second degree, third degree, respectively, for primary, secondary, and tertiary alcohols. Now, primary alcohol has the carbon atom to which, let me use the example of butanol, e.g. butanol isomers. I'm going to use the isomers of butanol to explain the difference between primary alcohols and tertiary, secondary, and tertiary. Now, the primary alcohol has the carbon atom to which the OH is attached. This carbon atom is only attached to one carbon atom, one other carbon atom. So it has only one carbon atom attached. The carbon atom bearing the OH group is attached only to one other carbon atom. Let's look at the secondary alcohol. Suppose the carbon atom, which consists of the OH, has got a branch. Then the rest here, of course, we have the chain. 1, 2, 3, 4. So we have 1, 2, 3, 4 carbon atoms. So it's butanol, but this butanol now, the OH, if you look at the carbon atom to which the OH group is connected, it is connected to 2 other carbon atoms, carbon 1 and carbon 2. There are 2 carbon atoms attached to this carbon bearing the OH group. So we call that one a secondary alcohol. Now the tertiary will mean the 3 carbon atoms with the OH group. The carbon atom here will have 3 carbon atoms attached here. So you find that this carbon atom to which the OH group is attached, the carbon atom here is connected to this carbon 1, carbon 2, and carbon 3. So we have 3 carbon atoms, and here we have 2 carbon atoms attached to the carbon atom bearing the OH. And here we have only 1 carbon atom attached to the carbon bearing the OH group. So that's the difference. So that is the classification of 3 types of alcohols: the primary alcohol, secondary alcohol. Primary alcohol, you can see primary alcohol. Secondary alcohol, you can see there are 2 carbon atoms, this one and this one, connected to the carbon atom which is bearing the OH group. For the tertiary, there are 3 carbon atoms connected to the carbon atoms that is bearing the OH functional group. So our lesson ends there, take your time to study the uses of alcohols. Uses of alcohols in industry. As a beverage, of course, most common alcohol is ethanol, which is used for alcoholic drinks, and then you can look for other uses, including the use as a solvent. You can Google, you can do a simple research to get many uses of alcohols.